Today we're going to talk about vector analysis. Now remember, a vector is any quantity that has both a magnitude or an amount and a direction. You can't describe a vector without talking about the direction that the object is traveling in, for example. And that direction is often shown in the sign, okay, positive or negative. Generally, let's say an object is moving in the forward direction, that would usually be a positive. And if the object is moving in the negative direction, that usually would mean it would be going backwards. So that positive or negative tells us the direction, and we represent vectors with arrows, and we draw the arrow whenever possible in the exact correct direction. Now, vectors wear hats. Vector quantities like velocity wear a little hat on the top of them that's like a little half arrow. And some common vectors we've already talked about would be velocity or displacement, that was x. Force is a vector, and weight is a vector. And we haven't talked about acceleration yet, but that's going to be a vector too. So we have a lot of vector quantities in physics. Now, if a quantity is not a vector, that means it's a scalar, and a scalar can just be described with an amount. There's no direction to a scalar. You either have some of that quantity or you have none. You don't have it in a certain direction. There's no special little hat or notation. And it's always positive. You always take the absolute value because you don't have to think about the direction, so you don't have to think about positive or negative. It's like if you have mass, you can't have negative mass. You only have some mass or no mass, so it's always positive. The other big one for us right now is energy. Energy is always positive because you will either have some or you don't have some for now. And things like distance or path length, speed, time, these are all scalar quantities. Now we represent a vector by drawing an arrow. And we draw the arrow as accurately as we can. We draw it pointing in the correct direction, and we try and show at least the relative magnitude, the relative amount of the vector by drawing the length appropriately. You can actually draw vectors on graph paper and make everything exactly to scale, but we just don't really do that very much in this class. And whenever you draw a vector, you got to make sure you have a little arrow on it. And you always generally, if possible, mark the actual magnitude of the quantity. Here, this is a displacement arrow vector. So it's 20 meters is the actual displacement, the amount or magnitude of the vector. And then the direction is 30 degrees to the west of north. If you're actually looking at this would kind of be north, this would be east, this would be south, and this would be west. And so to find the vector, you go north and then you go 30 degrees to the west of north. And there's all kinds of different ways of describing this and using angles and stuff, and we'll talk more about that as we go. Now, something kind of interesting about vectors is that you can describe vectors in different ways, and you can break them down into parts, or what we call components. So let's say that we have a vector A, and I'm going to just color A kind of a pale yellow here, just so we know exactly what I'm talking about. That vector A, let's just say that I am looking at this and I am interested in going from this point here at the origin to this point here, okay? I can follow the pathway of A. I could just walk that pathway if this was a map. But that's not the only way I can get from the first point to the second point. I could take a different pathway. I could break this single vector down into two parts, two other vectors. one of those vectors being horizontal and the other vector being vertical. And if I followed that second path and I followed the horizontal vector until I reached this point here, and then I followed the vertical vector, I would end up at the same place. Okay? Essentially what I'm saying here, I'm going to erase these, I'm saying that these two vector parts or components actually add up to the main vector. In other words, the x or horizontal component of a vector plus the y or vertical component of a vector equals the vector. When we add vectors up like this, we actually write them, we draw them from tip to tail. Okay, you would start at the origin or the part that you're interested in, and you would draw your first vector. This is the vector tip. And you would attach the tail of the next vector to that tip. And then you're going to have two tips up here at the end. Okay, so look at how that's drawn. You're going to get lots of practice at this, okay? You're always going to draw it tip to tail. And then you'll have two tips together here at the top. That's okay. And what you get is a nice way to take a vector that is at some angle theta, and you can break it down into a horizontal part, an x vector, and plus a vertical part. And you're going to see how incredibly helpful this is. The most helpful thing is that it creates for us a right triangle with our x component on one side, our y component on the other side, and what we call our resultant vector, which is the vector that is the added up one, which is the one we're looking at. That becomes the hypotenuse of a right triangle. And if we have a right triangle, there are special properties of right triangles that allow us to do some basic math, a little bit of trigonometry. You would have learned this in geometry, to calculate the lengths of different parts of this triangle or the angles, the internal angles of the triangle. Now, to find the magnitude of the different vector components, we need to use some basic trigonometry. And trigonometry, it's a big word, but all it is it's a study of the relationships in the right triangle, okay? And so all we need to do is we need to understand that when we look at a right triangle, we have some basic parts. Okay, first of all, you have that 90-degree angle that makes up the right triangle, okay? And then you're going to have two acute angles, one here, and then you're going to have a second angle here. Now, those angles might be equal. They both may be 45 degrees. More commonly, they will not be equal. They'll be different. So let's take a look here at the yellow angle. Okay. Now, the hypotenuse of the triangle is always the hypotenuse of the triangle. It's the longest side. It is the side opposite the right angle. Okay. But if I'm looking at this yellow theta angle, then basically I can describe the other sides of the triangle. This would be the side opposite that theta angle, and this would be the adjacent side. Now, adjacent just means right beside. The adjacent leg always makes the angle with the hypotenuse, okay? And the opposite is the only side not connected to the angle itself. So whichever angle you're looking at, which side you would consider the opposite and the adjacent, those are going to change. But you always look for which side of the triangle is not connected to the angle, does not help make the angle. That's going to be your opposite side. And which side is part of the angle, makes the angle. That's your adjacent side. All right, now once we know those parts of the right triangle, then we can use basic trigonometry to find the magnitude of the different sides. All right, so there are 3 trigonometry things that we are going to learn: sine, cosine, and tangent, okay? Now, if I'm looking here at angle theta, right there, this is the angle that I'm talking about. So everything I'm about to look at is in relation to that angle. The sine of that angle is equal to the opposite side, which this would be the opposite side, divided by the hypotenuse. This would be the hypotenuse. The cosine would be the adjacent side. Let me write this here. This would be the adjacent side divided by the hypotenuse. And the tangent would be the opposite side divided by the adjacent side. Now, if you know the angle and one of those sides, any one of those sides, you can get the other. And if you know what 2 of the sides, any 2 of the sides, you can get the angle itself. And so you can actually use these relationships, sine, cosine, theta, and a calculator to help you figure out both angles and all the lengths of the sides if you're given enough initial information. It's very important. You are going to need to memorize these, okay? You just do. And we have this kind of cute little way of remembering it, SOHCAHTOA, where you would have sine being the opposite over the hypotenuse, cosine being the adjacent divided by the hypotenuse, and tangent being the opposite divided by the adjacent. So it's all kind of preserved for you in SOHCAHTOA, but I would definitely make an index card or put this on a piece of paper, write out sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, and write SOHCAHTOA. You might even want to draw the right triangle with the sides labeled for a given angle. You've got to memorize it. There is no other way of doing it. So you're going to have to study this a little bit, okay? Because if you this will not be given to you on a test, okay? You just have to know it. Now, we're going to practice a lot here. We're going to get a couple of worksheets where we're just taking vectors and we're analyzing them, breaking them down into their x and y, or their horizontal and vertical components. And then we're doing, on one of the worksheets in particular, we're doing those trigonometry calculations to get an answer, to solve for something. When you are doing this, you're going to need to mark your angle. Most important thing though here, folks, you are going to need to use 2 colors. Use one color for the X all the time and another color for the Y all the time. For example, use red every time you draw an X component vector arrow. I would even use it to write out and do the math. Then use maybe blue. You know, I don't care what colors you use, but use blue maybe for the vertical component. But keep them separate. I want you to teach your eye to see it this way. And the colors help much more than you would think they might. You're going to label the X and Y components with their correct magnitude, and you're going to use the proper trig functions. You need to watch your sign, and we'll talk about that in a second. Let's do an example together. Okay, so I have a situation here, and I'm going to just add a couple numbers from the problem, which are not showing up here. I have a dog. The dog is on like a chain leash. And that angle between the leash and the horizontal is going to be 40 degrees, okay? And the dog is kind of being pulled or held with a force. It would be a force of tension equal to 60 newtons. And that force of tension is represented by that arrow right there. It would be in the direction that the dog is being pulled by the chain. Okay? So for number 1, I'm going to draw a rough sketch here of the vector in question. I'm just going to redraw this vector, okay? And it's just to make it a little bigger, like such. This is going to be 60 newtons. I know that much, okay? And I know that it's going to make an angle of 40 degrees with the horizontal. So this is going to be 40 degrees. Now I can take that vector and I can break it down into 2 parts, a horizontal part and a vertical part. And those 2 parts need to make a right angle. And so what I can do is I can draw my horizontal part horizontally over about that far. It might be a little too far. And that is going to be that force of tension in the x direction. And then I can draw a vertical component. That's going to be your force of tension in the y direction. I'm just taking this is your force of tension and breaking it down. And that 40 degrees is the angle that the force of tension black vector, the resultant vector, makes with the horizontal. Okay, so this gives me my basics. Okay, and now let's say I want to know the value of those x and y components. Okay, what you're going to need to do is figure out the trig function that will get you the answer you're looking for. So if I want to find the x component of the force of tension, that's the pink vector component there, I'm going to need to use one of the trig functions, and I have in that case, this is the adjacent side to that 40-degree angle. And so what I can do is I can say cosine of 40 degrees is equal to that f, whoa, I just changed colors. My bad, give me 2 seconds. I try and keep this color-coded to make it easier, but my hand is in the way. So cosine 40 equals ftx divided by the hypotenuse, which is 60 newtons. That's your adjacent side, ftx, divided by the hypotenuse. That's cosine. And if I want then to solve for ftx, I need to multiply both sides by 60 newtons. I can't fit it in there. 60 newtons. That divides to 0, and I get ftx equals 60 newtons cosine 40. And when I do that math, I get like 45.96. I'm just going to round that to 46 newtons. Okay, so ftx equals 46 newtons. Now I'm going to do the same basic thing for my fty vector. In that case, I'm looking at the opposite side of the triangle to that 40 degrees. I'm going to have sine of 40. So sine of 40, giving myself a little extra room, equals FTY divided by 60 newtons. I'm going to need to multiply both sides by 60 newtons. That'll divide to 1. 60 newtons times sine of 40. So FTY equals 60 newtons sine 40. And let me do that one real quick on the calculator. I hadn't done that one yet. So that's going to be 60. And whichever calculator you have, it will do it whichever way. Okay, you'll have different ways to input that into your calculator. If you need help with that, just let me know. And in that case, I get 38.56. So I'm again going to just round that to a whole number because I did that on the last one. And 38.5 is going to round to 39 newtons. So this one's going to equal 39 newtons. And that's it. All you do is write the actual trig equation and then solve for the side that you want. Sometimes you'll have the components and you'll need to solve for the hypotenuse. Sometimes you'll have everything and you'll need to solve for the angle. We will come back and talk about how to do that later. For now, what you're going to need to do is memorize or write out and have those trig functions right there for you. Have a calculator. You can use Desmos on your phone or any free scientific calculator on your phone that has sine, cosine, tangent, or any calculator that has sine, cosine, tangent. And this is how you set it up and do it. Now it is your turn to practice.